Hello and welcome to In Stitches. Today on the bench I've got this lovely Elna Supermatic Star Series machine. Model number, if I can read it, yeah, 62C. Model number. Now this machine had absolutely no power. Plugged in the good foot controller, turned this power switch here was on already. I had been toggling that to test with the original controller. Plugged in the good known foot controller and turned the power switch on, and there was this almighty bang and a big flash from this end of the machine. Gave me a bit of a fright. There was no smoke or anything like that. So I'm really just here today to get in here and take a wee look at what could possibly have gone wrong with this machine. I suspect it's capacitors, but I'm not 100% sure. There could be some other issue. So whether I actually get to the point where I can fix this machine today on this video, I'm not 100% sure. I'm just, as I say, going in there to take a look. We'll assess it and see how we go from there. So yeah, don't expect a happy ending as such to this video as a full repair or anything like that. Really just taking a look to see what we've got going on here. So I thought, first of all, it's probably a good idea just to maybe remove this panel here, just to have a wee look-see, just to see if there's anything obvious going on at this part here. Now, the only thing I can really put it down to is capacitors at this stage. You know, you wouldn't expect a motor to sort of blow up like that. Just a quick note too, before you go taking this panel off here, don't have the power plug plugged in. Now, the difficult part with these machines is that if the motor needs to come out, I think the this bottom part has to be split off. I'm not 100% sure. Might be able to extract it. We've got to take the base off. But let's have a wee squiz in here. There's a little bit of black residue. I'll see if I'll get some light on the situation, because there's some black residue here. Oh, actually it's this little component here is blown. To be honest, I mean, that looks like a resistor or something. To be honest, I'm not 100% sure what this here is. In fact, if I remove this panel here, we'll be able to get a closer look. Yeah, you see this component here? That has blown. Bit of scorching, and this component has gone kafooey. Let's take these terminals off. We'll have a close look. We'll see if we can diagnose. So the funny thing is that although I said it was capacitors with these machines, with machines in general, that when you get that explosion like that, generally it's capacitors. Well, I've never seen a capacitor blow in one of these Elnas. You see it all the time with the Bonina 830s and the 800 series machines. But these capacitors, they seem to be fairly robust. Pays to, take a photograph or something before you go pulling a machine like this apart, as far as, the electrical connections and things like that. Just good for reference. You can see there's quite a bit of scorching in here. Bit of soot. But that switch there is, as far as I know, I think it's just for the light, isn't it? I'm just not too sure. I can't quite remember off the top of my head now whether that powers the, machine, turns the machine off and on. As far as I remember, it's just bulb. So this component blowing here is potentially all that's wrong with the machine. Now, I probably need to refer to a wiring diagram just to figure out exactly what that is. But it looks like a resistor or a choke or something like that. I'm not 100% sure. If we have a look here at the service manual, here's a wiring diagram here for this machine. There's a couple of different variants, but if we have a look here, this area here. This is the light, that one there with the cross through it. And this one here is the inductor. That is an inductor. There's a switch. And there's the inductor. There's another inductor inside the foot controller plug. That's this one up here, leading to the middle pin here. That'll be that inductor there. This inductor here is the one that's blowing in the machine. Now, I'm not 100% sure if it's actually required, but I assume that it's to do with maybe an inrush current to the bulb or something like that. I'm actually wondering whether, because if you look at this 12 here, that pin there, that's from the wall plug, right? So that could be phase or neutral. I'm not exactly sure which one is which. You got 11 and 12, that's your wall socket plug, right? Let's just assume that 12 is phase. Well, then, the power comes through effectively, it is AC. So, but effectively, if we think of it as coming through here, down through the inductor, if the switch is on, the light runs there, back out to neutral, or if we carry on coming through here, there's up to the motor windings, right? And basically these motor windings, there's two big inductors there, right, effectively. So it must be something to do with, is it inrush current? I'd be happy if anyone would like to comment, if there are any electrical engineers out there watching. I'd be happy to hear your thoughts on that, as to whether this here could be just linked directly without that inductor, because effectively that would fix the machine, I'm sure. But whether it's safe to do so, I don't know. I don't have the values of the inductor either. I guess the inductor could be measured, but yeah, happy to take any suggestions if there's anyone there that knows more about that than I do. But I've got another machine here that I thought I'd just remove the side panel on. This is a similar era. This is a old aspect machine. You can tell the difference between the two aspects, the old and the new, by the dial. Someone's put a nice big monster sticker on there. But the differences between the old and the new is basically, you can tell by this dial here, looks is a silver colour on the new aspect, and this button here on the new aspect is square, sort of a square, like a cube type arrangement. That's just a quick, easy way to tell between the old and the new aspect, this one being the old. But let's have a quick look down in here, see what we've got. You can see there that we have a nice happy inductor. That's that reddy brown coloured one there. I think that potentially that's all that really needs replacing on this other machine. I guess I can test that theory by taking this here out of here and putting it into the other machine. Actually, what I could do is I could have a wee look around and see if I've got any spares of these panels here, which may have a good inductor. But before I go doing that, because I don't really want to, if there's another problem somewhere else, I don't want to blow this inductor. And what I thought was maybe I should test the two foot controllers to make sure that their wiring is identical. So let's do that. We'll get the multimeter here. Now I'm testing the original foot controller here, right? So bear in mind that when I plugged this in, there was no power. So I'm expecting there to be an issue with this foot controller, or the wiring in the foot controller. And so we can test that with the multimeter here. I've got it in continuity mode, which means that when you, if you have a piece of wire between the two probes here, and that wire is, connected through, if you know what I mean, that's what they consider to be continuity. And so you can test that by just joining the two, which implies that there's wire in between the two, let's say, and you get the beep, right? And so if I put a probe on here, So one of these pins, that's the wall socket. Looks quite different to your socket you may have. So in the USA, have I got a USA plug? I don't have a USA plug here, but just suffice it to say that your US plugs are straight. So let's ignore this bottom pin here, that's earth, which is not used in this system at all. Okay, so just ignore that bottom pin. These two pins here are the ones that go into the wall. Ours are angled, right? Yours are straight up and down. So they are the same thing. We do use a different voltage here to a lot of countries. We use 240 volt here. And I know in North America you're 110 volts, so I think Japan is 110 as well. Europe is 220, 240, same as us, but Europe has a different plug again. So there should be a connection between these, one of these here and one of these connections here, right? There should be a wire that joins, we'll figure this out. There should be a wire that goes from that pin there to one of these. I'm not sure which one. We can test it pretty easily just by holding just hold the pin on there. So I'm just at that end pin there. Sorry, it's a bit hard to see. But yeah, we have a connection, right, between that pin and this pin here. So the wire goes all the way down the cable and back around and comes in through this plug, comes in, you know, up one of these cables here and in through here to there. That's got a connection there, right? The other one that should be connected based on the wiring diagram is this one here. And if I just put the probe in there, and that one there should be connected. Nothing. So this here is faulty in some way, and potentially, if we just a quick check here, yeah, don't try this at home if you're not comfortable with it. Get an electrician or your local sewing machine mechanic to take a look. But providing nothing's plugged in, you're okay. Unless you're dealing with capacitors, of course, they hold a charge, so you do need to be careful there. So we can see there that the connections are intact in here. You know, sometimes you can find that one of these screws has come loose and the wires sort of just flapping around in the breeze there, but it's not the case. So potentially there's a break in the cable internally somewhere, and that's something that takes a little bit more work to track down. So we'll put this foot controller aside. I'll label it as faulty. Effectively, yeah, the connection between the plug and this in here is broken. So the break could be inside here somewhere. Yeah. Anyway, we'll put that one aside and we'll work with the good known one. So that would explain why when I plugged that original controller in that it didn't blow the inductor. But when I plugged in this good controller, it energized the conductor, and the conductor just basically threw its hands in the air for some reason and threw its toys. So this being a known good controller, we should get connection here, right? So let's try the middle one first. Okay, that is the neutral, and I know that because our plugs are orientated where this is the phase pin and that is the neutral pin there. And I would expect to get a connection also on this here. So I'm just holding it on that end one there. Yeah, so that's phase. So this one here is phase, that is neutral, and we're getting a connection from the plug there. So effectively what's happened is the energy has come through you know, the system and just completely blown this here up. And this is a good way to test that the other machine is in, you know, in working condition. This one here, the one that's gone kafooey. Now there is a danger here that there's a fault somewhere in this machine. that caused the inductor to blow. So it's very possible that when I pull this inductor here and put it into the other machine, that it could do the same thing. If there's a fault bad enough in the other machine to do that. But to be honest, the electrics in these machines are super reliable. I've never seen a capacitor blow. So, you know, that's pretty good testament considering the amount of capacitors that I deal with in my daily job repairing sewing machines. Yeah, they must, those capacitors in these, they must be so rock solid. Now, I had a machine, it was an older one like this, the old Aspect machine, and I had it trip the breaker, you know, like blow a fuse. And I wonder whether it was because the inductor was about to give up the ghost. I'm not sure, but it just sort of runs through my mind. Either that or, you know, maybe the capacitor's going in that one, I don't know. So what I'll be doing is I'll be plugging in the foot controller cable, which I've got plugged in here now, to the machine when I test it. And I'll be plugging the power socket into my power board over here, which is just over here, with the switch turned off, right? So you don't have to be anywhere near the machine if it does fail catastrophically. At least if you're remote from it, you can switch, you know, you're clear from it, there's no danger. You can turn the switch on. If it blows up, you just hit the switch back off again. And, you know, if your contact breaker's still not tripped, well, you know, you don't have to do anything else apart from just remove, you know, the controller and whatnot from the system to make it safe, and unplug it from the wall socket. That cable, that's to the light switch. So yes, I confirmed it from the wiring diagram that this switch here just switches the light. So I'll go ahead and wire this back in. So I'll be basically just putting all these connectors back where they came from. So I'll come back when that's done. I've replaced all the wiring internally there, just screwing this back in. And for science, I will record this power up. I'm hoping there's nothing else wrong with this machine that's going to cause a catastrophic failure, but I will do this in a safe manner. I'll be plugging the machine in over here off camera. I will be facing away when I turn the switch on, just in case. Okay, here we go, and just about to turn the power on. Looks okay, just as the fire siren goes off in the background. Looks fine. No smoke, no flames, no flashes, no bangs. All good. Okay, oh well, there's the culprit. Bad inductor. Let's see if the motor's still in a happy place there. Yep, that's all good. There's another problem with this machine here. It's the decentralizing needle position there. I've done a video on how to unseize that. I'll link it in the description down below. But yeah, everything, I mean, yeah, there's a number of bits very seized up in this machine. It's not a happy camper. I noticed also there's a missing little circlip here. That's no huge deal. The other thing to check also is the cam stack gear. Is that intact? I'll do a full rotation there. So I'm just keeping an eye on this. This is another failure with these machines, is the cam stack gear breaks. So I just take that through a full revolution, turning that there, just got my finger on it, providing a very small amount of resistance there to that cam. And everything seems in order there. The other thing that goes wrong with these, it's not uncommon, definitely not uncommon for any machine really, is there's a plastic gear that drives the hook here, and that one is intact, but you just can't guarantee how long that's going to last for. But yeah, so I think that, you know, this machine's definitely worth pursuing as far as, you know, freeing up this needle decentralizer, and yeah, it'll make a really nice machine, I'm sure. At some stage the pinion gear, the hook drive pinion gear may break. At some stage the cam stack drive gear may break as well. But, you know, it's one of those things. It's a bit of a gamble with these machines. It's a bit of a gamble with a lot of machines of this era, actually, with the plastic gears in them. The Beninas, they fail, the cam stack gear, plastic cam stack gear fails in them. You know, they're a similar era, maybe even a little bit old, a little bit newer than this actually. But I mean, you can see that the machine's had a fair amount of use. The paint's wearing off here. You know, the paint is coming off here as well. So it's been well loved. You know, it's been used. Yeah. So I think at this stage I will leave it at that. That's a successful repair, and potentially an easy fix. It's really probably just a matter of figuring out what value that inductor is there and replacing it, or figuring out whether it's safe enough just to put a straight link in there and be done with it. I'll be having a chat to my friendly electrical engineer to see what he's got to say about that. I'll come back with a follow-up video if I figure out what's a good replacement for these. As you know, you can see here, you can grab one off an old dead dying machine and just replace it. I've never seen one of these blow, so that's probably a fairly uncommon failure. Okay, I'll leave it at that. As always, thank you very much to my patrons. Your support is greatly appreciated. Thank you very much for watching. We'll catch you in the next one.